if you are doing a hypothesis test related to pi, so you're doing categorical data, because you're talking about percentage of success, proportion of success in the entire population, then you'd make your hypothesis test. The value that you hypothesized for the value of pi would be right in the center. And then if you add one standard deviation, you'd be up to about this far. And added 2 standard deviations, you'd be up this far. So this distance between the vertical lines is the standard deviation of this null distribution. Similarly, when we are talking about doing a hypothesis test for a population mean, meaning a hypothesis test for mu, meaning you have quantitative data that you're hypothesizing about, then we know that the value from your null hypothesis that you hypothesized for the parameter is going to be in the center. And now what I'm telling you is that when you find the standard deviation of this null distribution, which you'll be able to get from the applet, this distance between these vertical lines is that standard deviation of the null distribution. Okay, so new concept here for section 1.3 is the standardized statistic. The standardized statistic tells us how many standard deviations that our observed statistic is from the mean of the null distribution. We just learned how to visualize how that standard deviation relates to this curve. What I am now saying is you can measure your own observed statistic in terms of those standard deviations. So for example, we know, for example, that your hypothesized value of the parameter will be right in the center of that curve. It'll be pi, right there in the middle. Let's say your observed statistic was right here, that was yours. And I were to ask you, how many standard deviations away from the mean is it? Well, you could say it's 1 because it's right on the vertical line. So if that is your observed statistic, you could say it is 1 standard deviation above the mean. And what that tells us is the standardized statistic equals 1. Let's say your statistic was right here on this vertical line, that your observed statistic was right there at that second line down. That would mean that your statistic is 2 standard deviations below the mean. So that means the standardized statistic is -2. Okay, so a positive standardized statistic would mean that your statistic is higher than the mean of the null distribution. And a negative standardized statistic would mean that your statistic is below, right? Because down here, we would indicate that it's below the mean by using a negative. If your statistic's up here, you would indicate it's above the mean by using a positive on the standardized statistic. So 1 would indicate 1 standard deviation above. 2 indicates 2 standard deviation above. -1 is 1 below, -2 is 2 below. And then you can have the decimals and fractional amounts in between as well. Please note, a standardized statistic bigger than 2 or smaller than -2 means, think about where that would be. It means your statistic is out here in the right tail, or it means it's down here in the left tail. It means that your statistic was unusual. It means it would have had a low p-value. So one way we can think about how standardized statistics relate to p-value is by saying, when you have a high standardized statistic in absolute value, like a standardized statistic like 2, 3, 4, or -2, -3, -4, that means your statistic is out in the tail, and it means you'd have a low p-value. 2 last things. First of all, we do have a formula here for standardized statistic. To calculate the value of a standardized statistic, you take your observed statistic and subtract the mean. That'll tell you the distance your stat is away from the center. Then you divide by the standard deviation, and that will tell you how many standard deviations above or below the mean that it is. And we'll do that in some examples in the next videos. If you have a situation where you are looking at categorical data and making a hypothesis about pi, then we will call the standardized statistic the z-score. If you have a situation where you're dealing with quantitative data and we are talking about hypothesizing mu, we call that a t-score. These are both standardized statistics. They're both calculated in the same way. It's just if you're talking about pi's and p-hats, you're going to call it a z-score. And if we're talking about mu's and x-bars, we're going to call it a t-score.